everyone, welcome to week 1, day 4 of the course. My name is Sloan Garelick and I'm a visiting assistant professor at Brown University in Providence, Rhode Island in the United States. I'll be walking you through the videos today, and the topic for these videos and tutorials is paleoclimate. Over the past 2 days, we've explored climate science data from measurements. We've looked at ocean and atmosphere reanalysis data and used remote sensing data to understand climate on land, ocean, and atmosphere systems. And these approaches are used to assess recent and current climate variability on timescales from days to months to years. Today, we're going to explore even longer timescales and learn about approaches for measuring climate in the past on timescales of tens to hundreds of thousands of years, or sometimes even more. And the term for the study of past climate is paleoclimate. So what is paleoclimate? The figure on the left is showing temperature change since 1860, and this data is based on observations and measurements. However, Earth's climate history extends well beyond 1860. The figure on the right is showing a geologic timeline of Earth. Earth itself is about 4.5 billion years old, and the climate has varied a lot over this time. But how do we know what climate was like before 1860 when we started having observations and measurements of climate? And this is where paleoclimate comes in. Paleoclimate is the study of ancient climates prior to the widespread availability of instrumental records. So what was Earth's climate like before instrumental records? This figure is showing past changes in temperature on Earth over the past 500 million years, with age on the x-axis and then a temperature anomaly on the y-axis. And you'll notice that there's been a lot of variability in the temperature on Earth over this time. And just to kind of orient ourselves, all the way on the right is present day, and the red dots are indicating future projections of temperature change, which we'll talk about in later days of this course. For now, we'll focus on the past changes and thinking about how we can reconstruct temperature and other climate variables using paleoclimate records. So why is it important to study paleoclimate? Well, this figure on the left is showing changes in temperature and CO2 over the past 60 million years. And this data is shown in the black lines in both of these plots. On the right, the colored lines are representing future projections of changes in temperature and CO2. If you compare the magnitude of change in some of these future projections to past climate states, you'll see that there are some periods in Earth's history where there were similar temperatures and similar levels of atmospheric CO2 as to what's projected for the future. This highlights one of the main reasons why paleoclimate is important. Past climate states can serve as analogs for future warming. So by using paleoclimate records, we can understand the response of Earth's climate system in the past in order to help us assess future changes in the climate system. This can also help us to evaluate the environmental response to these climate changes, and paleoclimate can also help to validate and improve models and their projections. So how do we actually know what the climate was like this far in the past if we don't have instrumental records? One approach for understanding past climate on Earth is using paleoclimate models. Climate models use mathematical equations to characterize how energy and matter interact with different parts of the ocean, atmosphere, land, etc., and simulate changes in the climate system. There are models that do this for current and future climate, but there are also models that do this to create simulations and reconstruct past climate. And we'll learn more about climate models later this week and the following week. Another incredibly important tool for creating paleoclimate records and understanding past changes in Earth's climate are paleoclimate proxies and archives. Archives are geologic and biologic materials that preserve evidence of past changes in climate. Some common examples of paleoclimate archives include speleothems, tree rings, ice cores, lake sediment cores. And each of these archives contains substances or features known as climate proxies, and those are what actually record the climate variable and the change in the climate. And these proxies can be sampled and analyzed using a variety of physical and chemical methods. Throughout the remaining tutorials today, we'll learn more about each of these archives and the types of proxies that paleoclimate scientists can measure within each archive to reconstruct past climate. In this first tutorial, we'll explore the Pages 2K network of proxy-based temperature reconstructions. And the Pages 2K network is a compilation of temperature reconstructions based on proxies that span the past 2,000 years. Through this tutorial, you'll understand types of paleoclimate proxies and archives that exist, and we'll create a global map of locations of the Pages 2K proxy record.